In this video, we will talk about Newton's third law. Newton's third law says that if object 1 exerts a force on object 2, then object 2 exerts a force on object 1 that is equal in magnitude and opposite in direction. In notation, this can be written as F sub 1 2 is equals to negative F sub 2 1. So here the subscript notation goes like this. F12 means force of 1 on 2. So the force is coming from object 1 and acting on the object 2. So force of object 1 on 2 is equals to negative of force of object 2 on object 1. Forces always occur in pairs. One object cannot push or pull another object without experiencing a force back. We often call these action-reaction pairs. The forces are equal in magnitude and opposite in direction. But again, they act on different objects. So if you are doing a free body diagram, then these two forces are in different free body diagrams. So Newton third law action reaction pair cannot be in a single free body diagram of single object. It will be always in two different free body diagrams. Now let's look at an example. When the swimmer pushes on the wall with her feet, she exerts a force on the wall. By Newton's third law, the wall exerts an equal and opposite force on her feet. That force from the wall is what accelerates the swimmer away from the wall. The key is to identify the system of interest. If the swimmer is the system, the force from the wall on the swimmer is an external force that affects her motion. If you look at the free body diagram, you can see the weight force is balanced by the buoyant force. So in the y direction, there's no net force, so there's no acceleration in y direction. And in the x direction, the external force is coming from the wall on the feet of the swimmer. So that external force will accelerate the swimmer in the negative x direction if you say the right side is the positive x axis. And these two forces are the Newton's third law action reaction pairs, and these forces are acting on two different objects. So the F wall on feet is acting on the swimmer, F feet on wall is acting on the wall. So when you draw the free body diagram for the swimmer, this force F wall on the feet is there, but F feet on the wall is not belongs to this free body diagram, and we don't draw it there.